Good evening, YouTube. Hello. Once again, I'm Greg from GregsTutoringNYC at gmail.com. Doing a bunch of videos here about mostly about math, ELA, the state tests, things like that. I've been tutoring for a few decades, and let me see if this is running on my thing here. Tutoring for a few decades and doing a bunch of series about grade 8, 7, and 8 math right now. For a few reasons. If you go back to the first, second, and third one, which focus on grade 7 New York math state test, you can get some idea more about that. Let me see if I'm going through live here. Let me see if this is running on my thing here. Tutoring for a few decades and doing a bunch of series about grade 8. Okay, seems to be running all right. So let me plug that in, put that over here, just to make sure the stream keeps going. So what I'm going to do is at this point just jump into this, because I've done a whole bunch of these already. So why don't we just jump right into grade 8 math here. We're doing a sampler of some of the stuff from the New York State test for grade 8. So, whoops, I think we just messed up the screen. Let's see what we have going on. Let me shrink me down. Did I just mess that up? Let's bring that to about there, I think. Actually, I think it was larger than that. Yeah, probably to about there. Okay, so once again, when you start a test, read all the instructions, read the directions, start from page 0, the front cover, page through each page. You'll notice that there's also a reference sheet that you're going to end up passing. Okay, so this is part of the reference sheet that they're going to give. This is grade 8, so there's a bunch of formulas and some conversion tables. Okay, so why don't we just jump into question number 1. Again, you can pause this video at any point you want to. I'm live streaming this right now, so hopefully it all goes well. There's no technical glitches or mathematical errors that I make on top of things. My voice is giving out, so it's already almost 11 p.m. Everybody's asleep, so I'm going to just pound out one of these. This is requested by some people. I'm trying to help them out to try to gauge things out. So let's just start up with question number 1 and see where we end up. So this is a grade 8 test, grade 8 math, which means it's applying to all math before that. Grade 2, grade 3, grade 4, grade 5, grade 6, grade 7. Okay, grade 8 math encompasses grade 8 stuff and everything before it. Realizing too that your grade 8 test, if it's going to be on May 4th or so on, it's not including all of the grade 8. It's including all of grade 7 and the beginning part of grade 8. Okay? If it was that, it would have a test towards the end of June, more like the read-ins. The read-ins covers your whole grade. The grade you're in, plus the ones before it, obviously, with the prerequisite work. But in this case, this is really focused on grade 7 and half of grade 8. Okay? Alright, so let's jump into the first problem here. Mr. Thompson is buying 2 types of gift cards. Let me just see if this is running. It looks to be okay. Okay, Mr. Thompson is buying 2 types of gift cards to give as prizes to employees at a company meeting. He will buy restaurant gift cards for each cost $50. He will also buy movie theater gift cards that each cost $20. He has $450 to buy a total of 15 gift cards. How many of each card? Okay, there's a whole bunch of numbers flying around here. Let me just give myself a second to read this to make sure I understand it. All right, let me bring up a note thing in the meantime. So let's see. Restaurant cards are $50 each. I'm going to use RC. Restaurant card is $50 each. What else do we have going on here? A movie card is $20 each. Total money, he has to do this with is $450. Let's get rid of that. Total is $450. And he is going to buy a total of 15 cards, which means the number of restaurant cards he buys and the number of movie theater gift cards he buys is going to be 15. He's not buying 10 cards, he's not buying 20 cards. It's telling us explicitly he's going to spend $450 exactly, not up to $450, exactly $450, and he's going to buy exactly 15 cards, some mixture of these cards, okay? So how do we handle this? This is a good question. By the way, this one's closer to a SHSAT question. It's also close to a Hunter College High School question. This is the kind of questions they ask on that. Little more twisty to this, but this is straightforward up. So this is a nice meaty grade 8 question here. All right. If you're not sure how to do this, one way to do it is brute force. So what we're going to do is, let's try that as strategy number 1. What we have here is they give us a list of restaurant gift cards, and they're also going to give us a list of movie theater gift cards. So some combination has to be equal to the 450. So let's just start from D. If he buys 12 cards, restaurant cards, and a restaurant card is $50, okay, that's already 600. So D's no good. Okay, if he buys 10 restaurant cards, that's already 500. C is no good. Once again, because we're trying to shoot for $450. So that's already too much. So C and D are thrown out the window. Okay, then we come to B. He has 8 cards here. So that's $400. Okay? So he has 50 left over. He has 7 of these cards. But they're worth 20 each. So that's going to be 400. Plus that gets 520. It's bigger than the 150. 450, so that's no good. Okay? The last choice, the only one left if we do all the computations left will be A. So this is 250. 5 times 50 is 250. Okay? And 10 times 20 is 200. So 250 plus 450. And that allows us to use, meaning choice A wins. So we brute forced it. That took a lot of time. Of course, one problem is I started from D, then I did C, then I did B, then I did A. If I read the problem and started with A, then I would have gotten it straight off, and it wouldn't have been too bad. Okay? What I like to do is feed this back into the question, see if it makes sense, see if there's anything unturned, see if there's a phrase or a particular twist to the question that we didn't catch right. So let's read it through again. Let's feed the answer back into the problem. Mr. Thompson is buying 2 types of gift cards. So he's got 5 gift cards of the restaurant and 10 gift cards for the movie theater. Good. To give his prizes to employees at a company meeting, fine. He will buy restaurant gift cards, 5 of them, at $50, so that's $250. He will also buy movie theater gift cards at $20. That's 10 of them at $200. He has a total of that for $15. So it turns out 5 plus 10 is 15, and $250 plus 200 is $450. How many of each type will we buy? So it all matches up. Okay. Turns out there's another way to solve this as well. We can do it algebraically. So here's what we're going to do. Let's simplify this and say the restaurant is just R. This will just make our expression easier. So we're going to come up with an expression that 50 times the restaurant cards plus 20 times the movie theater card is going to total up to $450. Can everybody see that? So even if we take A and we feed it back into here, we get 50 times R. R is 5. Okay, in this case, up here I use it as the dollar amount, so maybe I should keep this as restaurant card as $50, okay, because I'm really using a different symbol here. The RC was the dollar amount. In this case, we're putting the dollar amount down in our expression, but R is the number, the count, the number of these cards. How many restaurant cards are there? Same with M is the count, the number, and the 20 is what it's worth. Okay, and 450 is the total. So what can we do with this? The answer is we can't do anything. We don't know how many R's there are, and we don't know how many M's there are. But we know something else. So if we run through the sentences, Mr. Thomas buys 2 gift cards. He'll buy restaurants at a 50. He'll buy movie theaters at a 20. He also has 450 to buy a total of 15 cards. So we also know that R plus M equals 15, right? The number of restaurant cards plus the number of movie theater cards equals 15. So now we have this 2 equations set up, and we're going to try to play around with them. We can now say R equals something, which is M minus 15 minus M. Or we could also say M is 15 minus R and substitute it into those expressions and get the distributive property. In other words, if we subtract M from both sides, minus M here, and we minus M here, we end up getting R equals 15 minus M. And then if we come back up to the expression, because it's 50 times R, it's going to be 50 times 15 minus M plus 20M equals 450. Okay, so now we only have M's. We threw R away. Okay, so now we have, we can do the distributive property. So we get 50 times 15 minus 50M plus 20M equals 450. And 50 times 15 is what, 750? Let's double check that on the calculator. 50 times 15 is 750, yes. So now we have 750 because we have minus 50M and plus 20M, we have minus 30M. 750 minus 30M equals 450. So what we can do is subtract 450 from both sides. And we get 300 minus 30M equals 0. And if we add 30M to both sides, we get 300 equals 30M. And if we divide both sides by 30, we get 10 equals M. Okay? And the M represented the movie theater cards. But we come back to here, we see that it's 10 there. Okay? And if we come back to the original expression, any of these actually, it could be this one here. We feed M in there and we can figure out what R is. This one's simpler. If M is 10, then R must be 5. Okay? Therefore, by substitution, substitute M and get R equals 5. Okay, and that should jive up here if we do the other expression as well. If M is 10, that's 200. So 200 subtracted from both sides gives 250. 50R equals 250. Divides both sides by 50. And R is 5. Okay, so it jives there for well. Okay, there's still another way to do this, which is that if I take the two of these, we can still do this algebraically. So both the techniques so far are fine. Okay, what we could do is we're going to try to figure out how to subtract the two of these. Okay, so if I multiply the second line by 20, the whole thing by 20, the left side by 20 and the right side by 20, means I'm going to get 20R multiply m by 20, I'm going to get 20m, and 15 times 20 is going to give me 300. Okay, so what I'm going to do is actually subtract these two equations from each other. So 50R minus 20R is going to give us 30R. 20m minus 20m is going to give us 0. And 450 minus 300 is going to give us 150. So now to get R by itself, we're going to divide both sides by 30. Okay, and then we end up with R equals 5. Okay, and it plugs back into there, and again we can go back, and the previous example we figured out M and we got R. In this case now we have R, and we're going to end up, when we plug it into the original two equations by the substitution, we're going to find that M is 10. Okay, so this is a QT problem. Let me just double check that I did this right. Sampler 2, grade 8 is A. Good. Okay. So we kind of beat that to death. Let's just make sure that this is following us with that. Yes, it is. Okay. So this is actually a good problem, and the infrastructure for it is a common technique to do a lot of different problems. Because we could do a table flip on this. Some of these numbers could have been harder. The answers could have been harder as well. This also could have been a show you work problem. So at least with the multiple choice, we have a mechanism to at least understand the problem and brute force it in. But you should really understand the algebraic solution as well, so that if you have a real world problem, because that's what a lot of this is about, it's not just passing tests, it's being able to think out of the box and use what you know for different contexts and so. Okay, so there's that. Let me just check that we're going okay here. Yes, that seems all right. Okay, so let me come back here. Okay, question number 2. Solve the system of equations below. Okay, oddly, this is similar to this. It has two equations, and we're going to solve them together. Okay, so if we do similar to what I just did in the previous example, which is we subtract the two from each other. What we're going to get is 2x minus 2x is 0, 4y minus 4y is 0, and then 10 minus a minus 10 is 20. And that ends up saying that we have 0 equals 20. And that makes no sense. So we can't do this. There's no solution. At least I believe that's the answer. Yep, that's the answer. No solution. So the answer to number 2 is C, because it just doesn't follow. Okay, it breaks. Okay, Kevin moved. Question number 3. Kevin moved from a city to a small town. The population of the city is 6 times 10 to the 5th, which is about 15 times as great as the small town. Which expression could represent the approximate population of the small town? Okay, so there's some estimation going on here. It's about 15 times as great, and they're asking for the approximate population of the town. We're told that originally the city is, the city, not the town, the city is 6 times 10 to the 5. And the town is about 15 times as great, or it's about 15 times as great. So we had this example in the grade 8 sample 1, I think, where I went through a lot of permutations with how to decipher 10 to the whatever and so on. And there's a couple ways to do this as well. So let's get out the notepad and see where we can go through this. I'll try to do this as quickly as possible. Again, reference back to sample. This is video number 5. Go to video number 4 to a question like this. I believe it was question number 1. I could be not remembering that correctly. So there's a few ways to do this. The straight up way is we have 6 times 10 to the 5. Again, I can't get exponents here, so this thing is a shift 6, which is called a caret. So I have 10 caret 5. Make believe that's 10 to the 5th. Okay? And what we know is that the small town, this city is about 15 times as great. So it seems to me that if we take 6 and divide it by 15, we're going to get some value there. Okay, so bring up our calculator. 6 divided by 15, and that's 0.4. So that equals 0.4. That means what we have is the small town is 0.4 times 10 to the 5th. Okay? So, I wrote 4, 10 to the 5th. So if we look at the answers, none of those are there. So if it did this right, we have a bunch of 9 stuff there. That doesn't seem to work. And we have 4 times 10 to the 4th and 4 times 10 to the 3rd. So why don't we try to metabolize this instead of something with a decimal point with the 4? Let's try to figure it out. So if we multiply the 4 by 10, in other words, the 0.4 by 10, so we get 4. What do we have to put there? So if we multiply this by 10, we need to divide this by 10. Okay? Because if I have A times B, and I multiply A by 10, I have to divide B by 10. So all we're doing is metabolizing it. A times B, if we have times 10 divided by 10, those cancel out. So if you remember, it was the exponent represents the number of zeros when you're talking about exponentializing 10. So this becomes 4. So if you multiplied 0.4 by 10, we divide it. So we're getting rid of a 0. So we have 4 times 10 to the 4th. So the answer should be B there. Question number 3 is B. Yes, okay. Again, we could use longhand to do this. So 6 times, so 10 to the 5th means 1 with 5 zeros. 1, 2, 3, 4, 5. That gives us 6. Okay. And if we did that divided by 15, okay, bring up the calculator. I'm just trying to do this without exponents right now. So 6, 1, 2, 3, 4, 5. Did I do that right? No, one more. Divided by 15. We get 40,000. 40, 1, 2, 3. And that's equal to 4 times 10. And how many zeros are there? 4. Okay, so it's also giving us the same mechanism to do that. Okay. There might be another way to do this. I'm trying to think. I'm exhausted at this point today. I've done like 3 hours of videos. I've been talking on the phone, and I'm half out of it. Let me take a sip of this. Okay, question number 4. A cylinder and a cone have congruent height and radii. What is the ratio of the volume of the cone to the volume of the cylinder? Okay, so there's a few terms here. One is a cylinder. It looks like a soda can. One is a cone. It looks like an ice cream cone. One is congruent. Congruent means the same size, the same shape, the same angles. So if it has congruent height, it means the height of the cone and the height of the cylinder are exactly the same. If they have congruent radii, so radii is the plural for radiuses, okay? So it means the radius of the cone is the same as the radius of the cylinder. Okay, and if we visualize some of this, it's telling us if we have a height, okay, that if we have a soda can, let's imagine here. I'm not drawing this to scale, obviously. it's touching the top of the bottom. So if I continue that out, it's going to kind of go through a layer like that. If I have a cone now, okay, so it's telling us that that height is the same, and it's also telling us that if this was the center, and from here to here is the radius, that this is the center. Again, I didn't draw the sail. It's the same size from here to here. Okay? And what is the ratio of the volume of the cone to the volume of the cylinder? Okay? So because the height and the radius of each respectively are the same, it means that we should be able to use the formulas. Okay? So you either memorize the formula or you can go back to see what they are. So we have the reference sheet. Okay? So a cylinder is this here. Let's get the highlighter out. Is pi r squared h, and a cone is 1/3 pi. I said pi. Yeah, 1/3 pi r squared h. So if you can see, a cylinder is pi r squared h, and we have pi r squared h here too on the cone, except it's 1/3 of it. So it seems to me that a cone is 1/3 of a cylinder, right? Can you see that relationship? In other words, a cylinder is equal to 3 cones when you consider its volume all packed together. So cylinder is 3 times of a cone, or a cone is 1/3 of a cylinder. So let's go back to that question. So it's asking about a cylinder and a cone, and then it says, what is the ratio of the volume of the cone to the volume of the cylinder? So we're looking for cone okay, that didn't work. Cone, CO, to cylinder. Sorry, my handwriting is atrocious here. So a cone was 1/3 to 1, or if we multiply both sides by 3, we get 1 is to 3, and that ends up being B. Okay? Let's double check that that's correct. Yep. Okay. Question number 5. Okay, once again we have something with an illustration. So we're going to ignore the words for now and see what we have going on here. So we have something about temperature conversions. We have a line coming through here. We're not seeing the other quadrants, but it's okay. In any event, we have an XY graph. X deals with degrees Celsius by half. Half, 1, 1.5, 2, 2.5, 3. And degrees Fahrenheit, starting from 26. By the way, if you notice, there's a little thingy here. I'm going to expand this out for a second. This kind of break, it's kind of a tear, because if you notice, it starts at 0 and goes immediately to 26. Otherwise, there would just be like empty grids there, okay? So we kind of don't care about that. We're only caring about from the 26 up. Okay, so in any event, goes from 26 to here. We notice that it starts at 32. It has a positive slope. We could actually compute the slope if we want. I don't know what the question is going to end up being. The question is actually, what's the meaning of the y-intercept? So the question is, the y-intercept is where x is 0, so it's where the line intercepts the y-axis. So it's intercepting it at 32. Okay, so now that we've looked at things, let's go back to the top. And the relationship between temperatures in degrees Fahrenheit and degrees Celsius is shown in the graph below. So if, for instance, going to find the thing where there's a dot here, it looks like 1 matches 34, and 5.5 matches 42. Okay, so what is the meaning of the y-intercept? Okay, so let me get rid of the highlighter for a second. All right, we got some weird kind of things here. What is the meaning of the y-intercept? The change in degrees Fahrenheit for every change of 1 degree Celsius. So 1 degree Celsius brings us to 34. 2 degrees brings us to 36. Actually, it doesn't bring us to 36. So it's the change in degrees Fahrenheit for every change of 1 degree Celsius. No, this is an exact point. This is a coordinate. It's 0, 32. So it seems to me that that it's not A. Okay. B. The change in degrees Celsius for every change of degree in Fahrenheit. No, it's the same way. So 32 to 33 doesn't seem to match the change in it's talking about the y-intercept, 0, 32 again. So it's not B. Okay, C. The temperature in degrees Fahrenheit when the temperature is 0 degrees Celsius. Yes, that's exactly what the y-intercept is, because it's 0, 32. It's x, y. So it's Celsius, Fahrenheit. So it's the temperature in Fahrenheit, 32, when the temperature is 0. Okay? So it seems to be C. Let's just run through D to make sure we're reading everything correctly. The temperature in degrees Celsius when the temperature is 0 degrees Fahrenheit. No. It's 32 degrees Fahrenheit. It's not 0 degrees Fahrenheit. Okay? And the Celsius is 0. So C wins. Okay, and that's question number 5. Yes, and that's C. Okay. Question number 6. Again, same thing to me, Jiggy. I'm going to ignore the words. I'm going to look at the thing here. So, seems like 7th and 8th graders took a trip. Field trip survey. I guess they're going on a trip. So, how many kids want to go to the sea? How many want to go to the mountains? Looks like the total's going up and down. So, 30 plus 50 is 80. Good. I'm going to double check the other way. So 28 plus 50 is 78. Yep. And then the totals of all the totals, 70 and 80 is 150. 72 and 78 is 150. All right. Okay, I got it. I don't know where they're going with this, but normally they have us do the totals. They did the totals for us instead. So let's go back to the questions. So the Ecology Club was planning to take a field trip to either the seacoast or the mountains. The club president surveyed all of the members to determine the preferred trip. The results are displayed in the table below. Okay, fine. Nothing's weird there. And it kind of jives with what I just said. Okay, which statement is true about the results of the survey? Okay, I'm going to bring the top off so I can bring question number D into here. Because I think the top words are not so significant in this exact word problem. Okay, so 20% of the 8th graders preferred the seacoast. So could it be that? So 8th graders, 30%, 20% of the 8th graders preferred the seacoast. Well, it's 30 out of 80, so that's already past 20%. So it's not A. 32% of 7th graders preferred the mountains. 7th graders, 32%. So 28 of 70. That does not seem to be 32, but let's make sure. 28 divided by 70 is 40%, right? So it's not. So it's not B. Okay, 40% of students preferred the mountains. So we have 78 out of 150. That's already past 50% because 75 is that. So it can't be C either. And 48% of students, so this is the only one left. Let's make sure it's correct and that we didn't goof up, make a mistake on any other ones. So 48% of students prefer the seacoast. So we're going to have 72 out of 50, or 75 out of 150 is 50%. So that sounds like, and let's just make sure on the calculator, 72 divided by, 72 divided by 150 is 48.48, which is 48%. And there we go. And everybody lived happily ever after and had a great time on that trip. Okay, let's just check 6 is D. Yes, okay. Okay, 7. Let's see what we got here. Okay, which equation represents a nonlinear function? So first of all, we know a linear function is in the form y equals mx plus b. So that means wait, let me fix this. I don't know what happened here. So a is in y equals mx plus b. That's y is in mx plus b because it means 1/2 of x. So m is 1/2 plus 1, so that's in the form. And this is y equals mx plus b, b complete half, that's no problem. M is 2. So the one that stands out different is b. Okay. Another consideration is that in a linear function, you can't have anything squared. Okay. We only have first order things. We only have x to the 1. Okay, we can't have x to the 2 or x to the 3 or something like that. So question number 7 is just straight up a more or less a definition asking what is a linear function or not a linear function. So 7 is B. Yep. Okay, alright, so now we're into the show your work examples. Let me just make sure we still have a connection. Yes, we do. Okay. Jude incorrectly simplified the expression 1/2 to the power of 2 times 1/2 times 1/2 to the power of 3 as shown below. 1/2 to the power of 2 times 1/2 times 1/2 to the power of 3 equals 1/8 to the power of 6 equals 1/262 144. Describe the mistake that Jude made. Okay, so they want it in words. So the mathematical problem is that when we run through here, let me use my pencil again. This is to the power of 2, this is to the power of 1, and this is to the power of 3. Okay, so this is not 3 times 2, that this 6 here does not come from 3 times 2. It comes from 2 plus 1/2 to the power of 1. There's an implicit to the power of 1 on anything. Okay? Because anything just by itself is itself. So this is 2 plus 1 is 3, plus 3 more is 6. So we have 1/2 to the power of 6. That's good. And what they did was they multiplied 2 times 2 times 2 to give the 8 here. But that's not what they were supposed to have done. So let's get rid of this so we can type the answer. So they don't want to see the correction, it seems like. It says they only want to describe what the mistake is. So Jude calculated the exponent correctly, but was supposed to leave 1/2 as is. In other words, it's the whole thing. Instead, he went within each or parenthesized expression, violating the order of operations. Right? If you remember this, I don't know how well this is going to work in terms of the person grading this, but PEMDAS is parenthesis, exponents, multiplication, division, addition, subtraction. Right? If we follow that, if we're doing exponents first, we don't go inside the parenthesis. So this is a violation of the order of operations, and the person did 2 times 2 times 2 to get 8 for the denominator. N was not supposed to even touch that. Yeah. Okay. Let's see. Is there? Oh, there is some more here. Correctly simplify the expression. So what we're going to have is, let me see if I can figure this out here from here. Let me try that. Does that work? Can I make that a fraction thingy? Yes, I can. Wait a second. This is confusing. Okay, wait. All right, wait. Let me get rid of this whole thing. All right, I think I just figured this out. So it's that. Okay, this is that. Okay, there we go. Yes. And this is a fraction. So what we should have is 1/2 to the 6th. Okay? And that's equal to, basically we're talking about, if I use the word, we're talking about 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So we're going to end up with another fraction, which is 1, and the denominator is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay, let me see if that's right. 2 to the 6th, with 4 times 4 is 16, and 16 times 4 is 64. Okay, yes, I believe that's correct. Is there an answer box for here? Yes. So it would want me to repeat. It's 1/64, I believe. Is there any units? No, there's no units, I don't think, right? It's just an expression. Alrighty. I guess that would be worth. Would that be worth 2 points or 3 points? So that seems a little more involved. This is saying 2 points. So, okay, question number 9. Oh, this is a cute one. Write an equation of a function that is not linear. So let's just kind of beat this around. Y equals mx plus b is one that's linear. Now b can be 0, and so can m. So what we want is, remember the aspect of that linear is not so much as the mx plus b, but that we're defining a line so that each x matches a y or something like that. So if we were to do something like, let's see here. The absolute value of x. That's not linear. If we did y equals, say, a quadratic formula, where is this thing here? If we did, for instance, x squared plus 1, that's not also linear. By the way, these kind of things, oh, that actually might be what the second question is. So use your equation to explain why your function is not linear. Basically, if you put values in, you'll see that it might create, if we have a thing like this, we're going to end up getting V-shaped things. or in the case of the one thing, a parabola of some sort. Okay, there's other twists and permutations to some of this. Okay, these are not straight lines. They are ricocheting off the axes and either as curves or subsets might be straight lines, but the whole thing together has to be one. All right, so we can put something like that. I'm not exactly sure what they're looking for here. This is kind of a weird question. Use your equation to explain why your function is not linear. I guess you could write something like, if I played through it, it's a parabola. It's not a straight line. When plotted, even on the second one, I don't know to what extent they're allowed this, but you can just say something like x squared is not allowed. Okay, I think that would get you through here. Again, they only wanted one example. So the point is, in case of this one, the first one, we could show that, in other words, the issue is if x is 1, then y is 1. But if x is minus 1, y is still 1. So that doesn't help it being a line. Okay? Yeah, I think if you focus on plotting it, maybe laying out a few points or something, you might be able to get a little further with that. Okay. It's kind of hard to say. It's kind of hard, people. All right, so let's see where we are. All right, so we're going to go to the next question. Question number 10, which looks like the last one. So we're going to do the same thing. We're going to go straight to the table. Okay, we're not going to read the words yet. Total amount of money from ticket sales. So, for instance, if I sold 13 tickets, I would have made, I guess, $146.25. So on. This does not look like a table where I'm going to be adding up the columns. It looks like there's a pattern here, actually. I don't know if we have to compute it. In other words, you might get the 108.75 divided by 7, the 177.50 divided by 18. I don't know yet. We haven't read the words. In fact, this half almost set up like a bank account problem, but it's not. It's about tickets. Total amount of money from ticket sales. Number of tickets sold. Okay, I don't have a clue what they're going to ask yet, so let's see. Tim is selling tickets to a school sporting event to raise money for his club. He put some extra money in a box before he began. Tim is selling tickets to a school sporting event to raise money for his club. He put some extra money in a box before he began. Okay, I don't see that in the table. Let's see where we're going. As he sells tickets, he records the number of tickets he has sold and the total amount of money in the box. Okay, so if I understand where I am so far, I'm not going to read the question yet. So if I take, for instance, this line here, the 13 and the 146, it seems to be saying to me that if you sold 13 tickets at a certain amount of price, yeah, I guess these tickets the same amount of money. So let's say, for argument's sake, each ticket was $10. That would be $130. And he puts a certain amount of money in the box beforehand. In this case, it would have been $16.25 to give the $146.25. All right. Some of the data before. Assuming the tickets are all the same price. Okay, so I made that assumption that they were $10, let's say. Write an equation that represents the situation in the table. Explain how to use your equation to determine the amount of money originally in the box before any tickets were sold and the price of each ticket. All right, let me just read this all one more time. You can read it quietly. Okay, this is cute problem. Let's see, same price. Okay, so let's move this up. Wait, I have to get rid of this. Right, I don't think these top words help us again. The problem is I need to get this on the screen at the same time. Wait, why is there a second thing here? Right, the answer box is gigantic. Okay, they want you to show your work. So here's what I think needs to happen. We can figure out the cost per ticket, because if we look at the difference between this and this, and this and this. In other words, we have let's see if this works. 146.25 minus 108.75, and that's going to be equal to the calculator. Let's move this over. Actually, is this going to show on your guys' screens? Yeah, okay, we're good there. I just double checked that. Let me just make sure we're live. Yes, we seem to be good. Let me check the phone. Yes, I guess we're good. So what we're going to have is 146.25 minus 108.75. Okay, and that's going to equal 37.5. And because that was the difference between the first and the second amount, and the difference in the number of tickets was 6. So what we're going to do is divide that by 6, and hopefully that's the price per ticket. Okay, so we get $6.25 a ticket. Okay, so if we take that and feed it back in, we should be able to figure out how much money he had left over. So for instance, if we spit that back in, so if we do 625 times 13 tickets equals this. Let's bring the calculator back. Times 13. That's going to give us 81.25. Okay. And if we take the 146.25, let's subtract that from 81.25. What do we end up with? 146.25 minus 146.25. We end up with $65. I did the subtraction backwards. Instead of 146 minus 81.25, I did 81.25 minus 146.25. I got minus 65. That means the answer would be $65. Okay, 65. So what we're going to do is feed that back in. So we have $65 with the original money in the box, and $6.25 was the other things. I'm going to double check it with, say, the 18 number. So I should be able to get $65 plus 18 times 6.25 should be equal to 177.50, and that'll double check that the numbers are right. So what do we have? 6.25 times 18 plus 65 is 177.50. Okay, good. Alright, so we're able to compute the numbers. Let's get rid of the calculator. Let's try to put the box up here. I'm just going to read through the question again to make sure I'm covering all the bases here. Tim is selling tickets to a school sporting event to raise money for his club. He put some extra money in his box before he began. As he sells the ticket, he records the number of tickets he has sold and the total amount of money in the box. Some of his data are shown below. Okay, good. Assuming all the tickets are the same price, write an equation that represents the situation in the table. Explain how you got your equation. Okay, so I've only got my numbers. So my equation is going to be the cost equals 6.25 times the cost. What are these tickets? Times the ticket plus 65. So this is really almost the y equals mx plus b situation. In fact, if we plotted it, we could probably see it's a straight line because there's the initial 65, which is our y-axis. Was it 65 or 60? Yeah, it was 65. Okay. 65 is going to be where x is 0, meaning no tickets are sold yet, and 65 is there, which is the initial amount. And then we're going to go up a straight line for every ticket sold. We're going to go up 625. So the x-axis is going to be the number of tickets. The y-axis is going to be the price, I guess. Okay. And let me see back here. Explain how to use your equation to determine the amount. That's more or less what I just said. So the answer is going to be this here. We would type that back into there. Okay, that's to show you work. The explanation would be the initial value would be 65. And each ticket T would increase the cost from that point by 625. Okay. And if you want to consider, it might be worth saying that actually the 625 is the slope. Okay, it's certainly the price increment. If you want to model this after the line, you could write that down too. Yeah. And the y-intercept would be 65 then, because that's definitely the model we're working off of here. I originally mentioned it looked like a bank account thing. It's interest rate rather, I meant to say, but it's not that. It's regular bank account kind of situation. And that's the last question. So let me go back to this a second. Let's bring me back. Okay, I am exhausted at this point. It's 11:41. I've done like 3 of these videos today. I've done some other stuff. So I wish everybody a lot of luck in all these problems. And I'm going to peace out with you guys. Again, I'm going to do some more of these still. And then I'm going to decide where to go from here. There's a whole bunch of other videos I've done, particularly about the SHSAT. I did some about the ELA test, which just happened. So if people want to review that, they can. There's other tests coming up, like the PSAT, the SAT. There's also the ELA part of the SHSAT and other tests. There's also writing stuff, which is essentially important to everybody. So with that note, everybody have a good night, a good sleep, and peace out.